I think what needs to be said to introduce Dr. Easterling is already been said. I would like to again express our sincere appreciation on behalf of the Agriculture Research and Development Agency in receiving a great honor from Professor William Ewart Easterling, who will be giving us a special talk on the adaptation of agriculture to climate change, lessons for Thai agriculture. Actually, Professor has already given a speech a day before yesterday, and it was very interesting because he was saying that one of the most important things that we should realize is that Thailand is going to be affected by global warming, one of a country which is going to be affected severely by global warming. So I think that what the minister was saying was very important, that we should be ready to get into action in research and development, especially in adaptation of the things that we will be facing in the near future. Dr. Easterling is a Nobel laureate, as you know, a great contributor to the award of the Nobel Peace Prize to the Intergovernmental Panel of Climate Change in 2007. This is together with the former Vice President of the United States of America, as you know, Mr. Al Gore, which is very famous on this subject matter also. At the present, Dr. Easterling is the Dean of the College of Earth and Mineral Sciences at the Pennsylvania State University. And before that, he was a director of Penn State Institutes of Energy and the Environment. Dr. Easterling has been involving himself with research interest, which is concerning with climate change. For example, climate change and food security, crop modeling of climate-plant interactions, and adaptation to climate change. This is to name a few. He also produced numerous publications about the effects of climate change on food and agriculture. Please give a very warm welcome to our special speaker tonight, Professor Dr. William Ewart Easterling.
Well, good evening. And Your Excellency, Mr. Secretary of Agriculture, and all honored guests, ladies and gentlemen, it is indeed a privilege to be able to stand before you tonight and talk to you about a topic that I think we should all be interested in and to some extent worried about. I was, a few years ago, as you now know, one of the co-awardees of the Nobel Peace Prize. And hearing all this so eloquently recounted caused me to think back to that very special time. And I remember that week that the prize was announced, and I was approached by a number of newspapers to give interviews. And so I got very good at this. And I was interviewed by the Los Angeles Times, the Chicago Tribune, and on the last morning of the week, I got a call at home. And this voice at the other end of the phone says, Dr. Easterling, this is Bill Smith from the Wall Street Journal. And I thought, wow, the Wall Street Journal. Well, I wasn't quite ready to take that call, so I wanted to get my thoughts in order. So I said, well, Bill, could I call you when I get to my office? And he said, yeah, sure. He gave me his number. And so I got my thoughts in order, and I went to the office, sat down with a cup of coffee, and called Bill Smith up. And I said, Bill, this is Bill Easterling calling you back. What can I do for you? And he said, well, Dr. Easterling, I really appreciate the call back. I was just calling to see if you wanted to renew your subscription to the Wall Street Journal. So not only did I feel somewhat embarrassed by that, but I may be the only person in the room who has deliberately called a telemarketer back. Well, tonight I would like to share with you some more serious matters, and I will, as the night progresses, walk you through some of the ways in which I believe climate change needs to be responded to, especially in agriculture. So, to be sure, we're living in a world today in which there are many changes underway, some social and some environmental. But one that I want to spend some time talking about is climate change. We know without doubt that the composition of the atmosphere is changing, and it's changing very rapidly. This slide that I'm showing you is of the CO2 measurements that have been taken from a very sophisticated monitoring station atop Mauna Loa in Hawaii that shows since the 1950s the steady upward track in atmospheric carbon dioxide. And we know from simple radiation physics that that is changing the energy of the atmosphere and is causing the lower atmosphere to warm. We also, as you look at the up and down oscillation, that this is indicative of the seasonal uptake and release of carbon as plants in the northern hemisphere begin to senesce or go dormant during the winter time, releasing CO2, and then begin to take CO2 back up in the summertime, which causes the CO2 levels to decrease. But the trend is unmistakable, and it is up. We also know from measurements from thousands of stations, high-quality stations, that the global average temperature of the Earth has been warming. It has been warming since the latter part of the 19th century and has accumulated about 3/4 of a degree of warming in that roughly 120 years. We also know that most recently, 2010 was the warmest year on record, and that comes after a slight downturn in the previous 3 years, which some who have questioned climate change had suggested that the warming was done and that we were starting to cool. Well, that's not the case. And we anticipate that there will be times in the future when the climate will cool a little bit before it continues its upward trend in warming. And this is a snapshot of stations across the world that have shown the January-December 2010 record, and you can see everywhere that there is a red dot indicates that it is warming. Only the few spots that you see on Earth with blue are places where there was any cooling in that year. Other parts of the climate system are responding to this warming, and as would be expected. The global average sea level has been rising. It's rising in part because as the temperature of the air warms, the water begins to slowly warm and expand. and that causes the sea level to rise. And we also are losing glacial ice in mountain glaciers that is contributing fresh water to the oceans and again, contributing to the sea level rise. We also know that Northern Hemisphere snow cover has been decreasing. And again, this is exactly as we would expect from an overall climate warming. We know from many studies that are shown here in shaded areas that 20th century growing seasons are lengthening. And if there were a study done here in Thailand, which I'm not aware of, I'm sure there have been some, it would show that growing seasons are lengthening. And we have seen in Europe, for example, a lengthening by as much as 10% of the growing season. This is in some ways a good thing, but it gives farmers an opportunity to grow different kinds of crop varieties that can take advantage of longer growing seasons. But it is an indicator that the earth is warming. Now, when we think about climate change and we hear climatologists talk about a global average temperature rise of 3/4 of a degree, many of us think, well, that's not much at all. But let me assure you that it is a lot of warming. The Earth has only warmed about 5 degrees Celsius since the end of the last ice age, the Pleistocene, 10,000 years ago. So the amount of warming that has occurred in 1 century is about 20% of the warming that we have experienced since the end of the last ice age. So that should get your attention. Now, another feature of climate change that's very important for you to keep in mind is the frequency of extreme climate events. We, again, speak in terms of averages, but we know that what really worries farmers and the public is when the climate does something quite severe. Like, for example, the incredible year that has been experienced in Australia with very powerful hurricanes and flooding. Here is a study that was done by a friend of mine at the University of Washington, David Battisti, who examined, using climate models, what would happen to the distribution of summers, at least Northern Hemisphere summers, as the climate changes out to 2090. And he looks at France, the Ukraine, and the Sahel. And what he finds is that in most instances, the coolest summers on record, or the coolest summers rather, predicted in the year 2090 will be warmer than the warmest summers of today. And in the case of the Sahel, by 2090, all but the coolest summers are warmer than the hottest summers in the current climate record. So that should give you a sense of the kind of challenge that farmers will be presented with as the century progresses. And not only will it get warmer, but we know that just from the physics of the water cycle on Earth, that runoff, a very important marker for water availability to crops, will change. This is a slide that was produced in the chapter that I led in the Intergovernmental Panel on Climate Change. And what you see here is on top a map of the simulated rain-fed crop production potential of Earth. And the greener the area is, the more productive it is estimated to be. And that's what it is today. What catches your attention is on the bottom, where we ran very sophisticated climate models in an ensemble mode, meaning that we put a lot of different climate model experiments together with common forcing variables. And we look at the estimated result of effect of climate change on annual runoff between now and 2100. And if you look at the first areas that I draw your attention to with these circles, the Mediterranean and Western Europe, let's just look at that for a moment. That's a very agriculturally productive region. But if you look down on the lower map, you can see that that region is expected to become much drier over the next 100 years. So that should give us pause of concern about farming in those areas. But on the other hand, there will be other parts of Earth that could experience a bit of increased runoff or increased moisture. An example would be in Siberia, in Russia, or perhaps down in Argentina in South America, where there may be opportunities presented by the warming to grow crops that simply do not thrive in those areas today. Now, one of the reasons why we argue, that adaptation is going to be crucial as climate changes is that climate modelers estimate that even if we were to dramatically decrease the composition of greenhouse gases in the atmosphere today, bring them all the way down to year 2000 levels, that we still are committed to about 3/4 of a degree of more warming. So that would be about the same amount of warming that we have already experienced over the past 100 years or so. So that's to say that it's as if the climate system has been pushed out to the ocean and left to drift with a momentum of 3/4 of a degree that we cannot avoid. So given that scenario, what do we know about the effects of this future climate change on crop yields? Because that's one quantity that we must know something about if we're going to protect the food security of the planet. Well, we have to take into account two things when we simulate the yield response to climate change. Using mathematical models, this is a type of modeling that I do, we simulate all of the different processes that a crop undergoes as it grows in a field. We do this in the computer, and we simulate both the effects of CO2, carbon dioxide, on photosynthesis. It has a direct effect on photosynthesis, which to some extent will offset some of the deleterious effects of climate change. And we have to, at the same time, simulate the effects of temperature and rainfall on the yields. So I'm going to show you a study that we did in the Intergovernmental Panel on Climate Change. And I apologize for the complexity of this slide, but it's a very important one, and I want to walk you through it very carefully. What you see here, what we did, was we examined almost 100 different studies that had been done across the globe looking at the effects of climate change on either wheat, rice, or maize or corn. And we divided the studies into those that were done in the temperate or high latitudes where European and US agriculture are practiced versus those studies that were done focusing on the tropics. And we further divided the studies into those that did not take any account of the ability of farmers to adapt to the changes from the studies that actually did simulate the effects of adaptation. So this is our way in the IPCC of trying to decide over broad reaches of the earth how cropping systems will fare under climate change. And so the red are the studies, the dots and the lines are the studies that are without adaptation. So that would be considered kind of a worst case. And the green is with adaptation, very simple strategies farmers might resort to, like changing planting dates or changing cultivars, and that's in green. And the reference line is blue, so everything above the reference line is above today's levels of yields, and everything below is the reference line is less than today's levels. So what do we see here? Here are the take-home messages. First of all, we see that temperate yields tend to thrive. They do okay with temperatures up to about plus 3 degrees Celsius. Now, look carefully at what happens in the tropics. Tropical yields tend to decrease productivity immediately. So very little, if any, buffer to the warming in the tropics, which I might add, of course, is where Thai agriculture is practiced. Now, simple adaptations do extend the temperate crop productivity out to about 4 to 5 degrees Celsius. But in the tropics, again, it only is modestly effective. So the picture that we consistently paint from these studies, and this is repeated over and over again, is that the tropics will be the place where yields will decline first, and while there may be some benefits in the higher latitudes to warming, especially in those areas in the highest latitudes of the grain belts where they are currently cold temperature limited, there will be eventually a decline in yields below present if the warming continues unabated. So what does the situation look like for Thai agriculture? Well, there is an accumulating research base that we can draw on that's beginning to give us a profile. For one, if we look at potential changes in cereal yields, just focusing on the region of Asia that includes Thailand, and we take the climate change all the way out to the 2080s, and in this case, we're just using one particular climate model to give us our snapshot of a future climate. We see that yield losses in cereals, all cereals grown in Thailand, is somewhere between 2.5% to 5% yield loss. So that's if there is no attempt to mitigate climate change. Now, in this second slide, we ask the question, what happens if we're effective through policies of our governments in limiting the concentration of atmospheric CO2 and all other greenhouse gases at 550 parts per million? Right now, the atmospheric composition is about 380 parts per million of CO2. But if we were able to stop the rise at 550 and stabilize it there, and the temperature and the precipitation and all other parts of the climate system were to stabilize, then we actually will see a yield loss that is less than the unmitigated climate change, between essentially no change and about 2.5% loss. Now, that 2.5% is an important number. That's not to say that it isn't, but it isn't as bad as what would happen if the climate were to change unabated. Here's another study that was done by Thai colleagues that shows the areas, again using crop simulation models, the areas where rain-fed rice was reduced by 30% or more. So you can look across the country and you can see areas here and there where rain-fed rice production would be somewhat disadvantaged by climate change out to 2080. And this is cassava, another important crop, and one that my graduate student from Thailand is working or has worked on in her master's program at Penn State. And these are not her results, but hers are very similar to this, showing the area of cassava crop yields that are reduced by 30% or more. So you can certainly see from this that there's going to be some real problems to be dealt with in crop production broadly across Thailand. Now, there's another aspect to climate change that will indirectly affect agriculture in Thailand, and that's sea level rise. Now, this is almost a different lecture to talk about sea level and what it could mean. But if the sea level were to rise by 1 meter, you can see for yourselves that there are sections of Southeast Asia, not so much Thailand, that would be affected by or inundated by that amount of sea level rise. Certainly, other parts of Oceania would be affected perhaps more, but this would be serious. And if it were to progress to 2 meters, now you begin to start to see parts of Thailand becoming inundated by sea level. And this would almost certainly affect fisheries and estuarine ecosystems throughout the country. I can't speak at length about this, but perhaps after my talk, if there are those who are interested in this aspect of climate change, we could discuss it. Now, one of the things I want to leave you with in this lecture is what I would call a blueprint or a set of steps that any nation should begin to start to formulate for adapting their agricultural systems to climate change, because the climate is already changing and time is passing, opportunities are passing. It's important that we start to do these things today and not wait, because as we as climate scientists know, the climate changes are likely to become more severe with time, and as I mentioned before, whether we do anything to stop the climate change or not. So, what is the first thing we should do? Well, I always tell my students that always expect that not only the climate will be different in 20 years or 30 years or 50 years, but so will society. So will the kinds of things that we care about in our everyday lives that have little or nothing to do with climate, but will influence our welfare as climate changes. And to always be aware of the fact that you're not, when you're analyzing the effect of climate change on food systems, you're not analyzing a future climate that we just simply impose on the world of today. The world will co-evolve with climate change. And in agriculture, this is especially important because we know that the demand for food is rising roughly in proportion to population increases. And this is just a recent UN population projection out into the middle part of the 21st century. And although it doesn't quite get us all the way to 10 billion people because of recent inclusion of declining birth rates in some parts of the world, and the impact of HIV/AIDS. But it is, in fact, a good indication that food demand will be higher in the future. We also know that per capita income rates have been rising virtually everywhere in the world, and they will continue to rise. Even the poorest countries are becoming wealthier over time, as indicated here by some World Bank numbers that are both historical observations and future projections. So as people become relatively wealthier and more numerous, this will not only add to effective food demand, but it will also change the types of dietary preferences that we all will have. We can expect, again, according to FAO, that by the middle of the century, we will be seeing diets that are much heavier in meat, sugar, oils, and wheat, and we can expect less consumption of rice, coarse grains, roots, and tubers. Now, this is at the global scale, so that's not to say that you would expect a lot less rice production or consumption in Thailand. I think that would be kind of a stretch. But you do get the point that as the world gets wealthier, our diets will certainly put yet another strain or challenge on the world's farmers. And what we all have certainly witnessed in recent years, the remarkable rise of biofuels as energy prices have risen with the expansion of the global economy. And although energy prices have taken a little bit of a rest during the global recession, there already are signs that as the recession begins to ease, that energy prices are beginning to rise again. So there will be increasing pressure to use a certain amount of our agricultural capacity to produce biofuels. And the question will remain in front of us: how much food can we possibly sacrifice to produce biofuels? It's a social question as much as it is a biological one. Now, world food production, for the most part, over the latter part of the 20th century on to today, has kept pace with food demand. But I can tell you that we're now starting to see a deceleration in the rate of growth of yields and production. And it is worrisome, to be sure. And this is without the challenge of climate change. We know, and this just happens to be a lot of graphs of wheat yields throughout Europe, but they might as well be anywhere in the world, that the annual yield growth through time has been strongly linear. And what that means, for those of you who are more quantitatively inclined, that back in the 1960s, when yields were a lot lower than they are today, any increase in yields on a linear path was a fairly large percentage per year increase. Back in the 1960s, we were increasing yields at a rate of about 2.5% per year. But today, that yield increase on a percentage basis is becoming smaller and smaller. It's down now to about 1.3% per year. And that just happens to coincide with the rate of increase in demand for food. So we know in the future that if we don't maintain a yield growth, whether the climate changes or not, above 1.3%, or at least at 1.3% per year, then we're going to risk falling behind growth in demand. And that brings with it a lot of unpleasant outcomes, including higher food prices and almost certainly more problems with famine and malnutrition, undernutrition. The number 2 step in my effective agricultural adaptation strategy is to understand the problems you need to solve first from a climate standpoint. Now, what do I mean by that? I couldn't find a commensurate slide with Thai agriculture, so I got one from as close to Thailand as I could find, and that's Chinese wheat production. And this slide shows different features I want to walk you through, but basically it is the percentage of harvests that are considered failed harvests because of climate change. First of all, the baseline percentage of yield failures in this part of China for today's climate is about 12%. So roughly 1 in 10 years would be considered a failed year from the standpoint of farmers' expectations. Now, if there were no adaptation at all to the climate changes extending out to 2080, then we would, over that time period, expect about 23% of the years on average. So again, about 2 in every 10 years to be failures, with a range of 14% on the low end and 36% on the high end. That's with no adaptation whatsoever. Now, if we were to develop high temperature tolerant cultivars that could handle the high temperatures of the unfolding climate change, the average number of years with failure goes down to about 16%, and the range is about 9 to 27%, so a pretty large range. Now, but we also know that the climate may change in ways that causes water to become limiting. So what happens if we remove all water limitations by providing adequate irrigation? Here we see 11% of the years are failures, with a range of about 6 to 25% on the high end of years. So by optimizing your water use, you actually are able to, even with climate change, bring the percentage of years in which there are failures down below today's average with today's climate. And the final piece to this is what happens if you remove both water and temperature limitations. And again, this is very optimized. It's not apt to be what happens in the real world, but it does show the potential for how you could adapt if you invested your efforts in trying to achieve removal of these types of water and temperature limitations. In this case, now you're down to just 3% of the years are failures with a range of 1 to 7%. Now you could ask, well, if it makes this much sense and it's this good with climate change, why aren't we doing it today? Well, we are, but we're not doing it with as much vigor as I think we would if we were experiencing a rapid climate change. So this gives us a good idea of what our researchers are going to have to shoot for in what they are trying to accomplish in giving us adapted crop varieties. We also need to invest research focused on these problems. So I'm going to make a strong pitch to Mr. Secretary that there be an investment in fundamental research that helps us understand the basic biology, for example, in this slide of photosynthesis and how it can be affected by rising temperatures and what you might be able to do about it. Now, in this work that was done by some Japanese scientists with the ultimate goal of trying to adapt rice culture to, or rice varieties to climate warming, They used a gene from Arabidopsis thaliana infused into tobacco, just as a test case, to see whether or not they could introduce a trait that allows the plant to continue to photosynthesize at a reasonable rate with temperatures beyond the optimum of today. And what we have here, what you see here is the wild strain. And I'm just going to point to one of the screens over here to my left, your right if you're facing me. And you'll see up here oxygen evolution, which is just another way of saying rate of photosynthesis. And the wild strain, as you can see over here, is producing at a declining rate as the temperature down here increases. This, on the other hand, is the genetically modified version of that same plant, and you can see that even with increasing temperatures, there's increasing photosynthesis out to a certain point before it begins to decline. So you're building into the plant the ability to absorb or withstand higher temperatures and still be able to effectively put on biomass. Fourth, we need to understand what it means to enhance resilience of a production system, and as opposed to preparing for an overall transformation of a system. Now that may seem complicated, so let me just explain it very simply and piece by piece. I'm afraid I'm going to have to resort to a kind of cartoon to tell you how the resiliency of a system is different from the transformation of a system. And to do this, I want you to picture up here on the screen and in your mind a national agricultural production system as a ball at rest in a valley. Again, I'm going to point to this one slide here, or this screen. In a valley consisting of many environmental and economic forces. So those forces kind of create the shape of this valley. Now, then imagine an external disturbance like drought or climate change begins to start to propel the ball up the side of the valley. And as long as that stress eases out or eases up before that ball crests the top of the mountain and goes into another valley, losing control of my control. It will eventually spring back and reassume the same set of processes and the same form that it had before. And you might think of it in the same way that you think of a rubber band. The system, the agricultural production system, is being stretched out by climate change, but then it eases a little bit, or the system makes certain adjustments to itself internally, and the rubber band snaps back into shape, and the system pops back into a sort of semi-steady state. That is what we would call a resilient agricultural system. But what happens if the force is sufficiently strong and sufficiently persistent, like climate change over many, many years? It pushes the ball up over the top of the valley wall, and just like you see down here on the very bottom, it goes into a whole new state, in a whole new valley, with a whole new set of economic and environmental forces. And that is what we call transformation. And this is not merely an academic idea. This has very strong policy implications to it. For example, in regards to resiliency, we know that farmers have today a number of tools that they can use for dealing with climate risk and managing climate opportunities and climate risks. And they don't have to resort to the government or any policy measures to be effective in managing these risks. For example, they can change planting dates in order to get the seeds in the ground in time for the rainy season, or to take advantage of the warming earlier spring conditions. And they can change cultivar maturity classes, again, to match up best with the length of growing season that is now before them. Or they can practice different kinds of moisture and soil conservation tillage, making the best use of what they have. They can deploy irrigation wherever that's economical and available and practical. And in a more extreme case, they can even switch crops or crop rotations. These are all tricks or strategies that farmers have at their ready to be able to use to deal with climate variability and change. This is what I call the first line of defense that farmers will have. But what happens when resiliency is exceeded? So if the climate change continues unabated, or if it happens more rapidly than our normal tools for dealing with climate risk can accommodate, then resiliency will almost certainly be exceeded unless we have prepared for an orderly transformation of agriculture. Well, let's translate that into something meaningful here for you. This is a study that was done by colleagues at one of the consultative groups on international agriculture, a group in Mexico that focuses on wheat improvement, CIMIET. They have developed what they call mega environment zones for characterizing wheat where it is grown throughout the world. And it just happens that in this slide I'm showing the current CIMIET zones for wheat. Again, over here you can see this is one particular zone in blue, and this is another zone of wheat that's differentiated by its growing characteristics in red. Here, on the other hand, is after climate change has gone to 2050, what happens to those same zones? You can see a northward migration of those zones. And that will result in a major transformation of agricultural production, at least that which is growing wheat in that region. And you can see this certainly will have implications for Thailand. Such a shift will almost certainly require a flexible infrastructure, new knowledge base. Farmers don't necessarily know right off the bat how to grow certain types of crops that are very different from what they have traditionally or historically grown. It may require mobilization of labor forces, which are very scarce in rural areas, as I know you know here in Thailand. And it will certainly require adaptive research from the major support institutions like ARDA here in this country. I want to give you an example of what I have seen as a major transformation in American agriculture that has happened historically, and it would be very similar to the kind of transformation that may very well occur in the future as climate changes. What you're seeing here is a portion of the United States that is in the Great Plains. This is in the very middle of the country, and it is the western edge of what you would probably call the American grain belt. Back in the post-World War II period, irrigation water was discovered at great depth under that part of the Great Plains, and technology was developed to bring that water to the surface, and it resulted in a big transformation of cropping systems in that part of the western Great Plains using center pivot irrigation into row cropping systems where corn, maize, and wheat were grown with tremendous yields under irrigation. But the problem was, and still is to this day, that water is very slow recharge groundwater. In fact, it is so slow that it is almost like pumping oil out of the ground. Once it's gone, it's gone. It doesn't recharge very fast, so it is essentially a non-renewable resource. And so over the years, what you see here in the red are some areas where the saturated thickness of the aquifers has decreased by hundreds of feet. And the pumping costs to bring that water to the surface became prohibitive. And so what happened? Did agriculture disappear in this area? No. What happened was, over time, there was a transformation, aided by the government and by the ingenuity of farmers. Farms became fewer in number, as many failed, but then they became larger, more economically effective, and they reverted to dry land agricultural practices. They lowered their expectations of yields, and quite frankly, they're doing quite well out in that part of the world. So this is just another example of the flexibility and the ingenuity of an agricultural system when facing some kind of resource limitation. Number 5, improving water conservation. I believe, quite frankly, that water is the linchpin. It is the key to successful agricultural adaptation, whether it be here in Thailand, whether it be anywhere else in the semi-arid tropics, even in the more post-industrialized agricultural systems of the north. So water, I think, to be extremely important. And as I said, it's a linchpin of climate change, and there are problems. As we like to say, there are storm clouds gathering on the horizon with respect to water. I believe that water will be in this century what petroleum has been for us at the latter part of the 20th and early part of the 21st century. It will become a major item of scarcity. And we realize right now we have a problem. About 1/6 of the people alive on earth today have little or no access to clean, fresh water. By 2025, by many different UN and World Bank estimates, that number will rise to about 1/3 of all people on earth will not have adequate access to clean, fresh water. We know from the Intergovernmental Panel on Climate Change that by 2050, the annual average river runoff and water availability will increase because of climate change in some high latitude areas and in some of the wet tropical regions. But it will decrease over dry regions at mid-latitudes and also in the semi-arid tropics. And I would include Thailand in that. We know already, because of the warming and the loss of glacial ice in high mountain environments, that some human communities dependent on snow and glacial melt for water are already beginning to feel the effects of the warming, and water is becoming more of a challenge. And the IPCC says, globally, the negative impacts of future climate change on freshwater systems are eventually expected to outweigh any of the benefits that you might have seen anywhere on Earth before that. Now, there are 5 water policy responses that I think are highly applicable to the situation here in Thailand. And these are what I call the 5, just sort of the golden 5 that you must be paying attention to. First and foremost, include adaptation and mitigation measures for agricultural water management in national development plans. It is astonishing to many of us in the scientific community at how little communication, at least historically, has taken place between the communities in charge of development plans at the national and regional levels versus those who are trying to develop plans for adapting and mitigating climate change. We need to get on the same page so that those plans are mutually reinforcing and complementary. Number 2, we need to develop and promote technical and management measures to improve the efficiency with which irrigation water is applied. We still have a ways to go in improving the irrigation efficiency on crops here in Thailand, and I would even warrant to say even in the most sophisticated post-industrial agricultural systems anywhere. Number 3, we need to improve the knowledge of climate change and share good practice amongst countries and regions. You cannot acquire too much knowledge, I mean to say, about climate change. Something that I think the scientific community could do a better job of is communicating what we know about the science of climate change and what its impacts might be and what kinds of adaptive opportunities are available to us. That needs to be a very vigorous dialogue that takes place between the scientists and the managing community, whether it be policymakers or resource managers on the ground. We need to do a better job, number 4, of promoting risk management in our national policies through better observations. We need to have a better idea of where climate change is happening, what the effects are, and it needs to be in real-time monitoring mode. And in addition, we're going to have to learn how to manage the actuarial risks of different types of climate scenarios in the future that will change the actuarial numbers significantly. Just as a side note, I heard a very interesting interview of a gentleman in charge of a non-government organization in Australia that deals with natural hazard insurance. And he was reflecting on the tremendous calamities that have occurred in Australia over the past year and a half, and you know, almost chuckling as he said, you know, we've had 100-year events 2 years in a row, and it's true. And his main point was that it's not that we're going to have to, you know, spend more on insurance. It's that we're going to have to start to learn how to manage risk differently and take into account that the climate is changing, something that insurance companies and governments in charge of insurance have not done so well in the past. And finally, mobilize adaptation funds to meet the challenges of water and food security under climate change. Some concluding thoughts. I think, looking forward, that we don't have the luxury of deciding whether or not to adapt to climate change in agriculture. We will adapt or else fall behind and see major problems begin to develop. Not all forms of adaptation will reduce vulnerability indefinitely. In other words, we may strive to try to keep the same agricultural systems, the same crops that we currently grow in Thailand, but there may come a time when the climate changes are too severe, too rapid to be able to make that happen successfully. And when that occurs, we better have a plan for how to transform agriculture little by little into something that looks different, but essentially gives us the same services that we need to satisfy society. And finally, a national agricultural adaptation policy is a must. I think every country, in fact, even regions within countries, must develop these plans to help avoid any kind of unpleasant surprises. As I like to tell my students, it's better to manage risk than to manage crisis. So thank you very much. I appreciate your attention. And let me just say before I stop to entertain questions that had the Prime Minister been here, I would have said that there are very few investments that one can make in the future that bring returns long after a political lifetime, perhaps even after a biological lifetime, that will be revered more and respected by future generations than those very difficult decisions to invest scarce resources in a problem that you can't really see, you can't feel definitively today, but you know that you have an obligation to help those in the future have the same level of welfare and livelihood that you have been able to enjoy today. So with that, thank you very much for your attention, and I'd be happy to entertain some questions.
Dr. Easterling, hi, my name is Hart.
Hart?
Nice meeting you, sir.
Good to meet you.
Wow. Okay, thank you very much, Dr. Easterling. Right now, we would like to ask everyone for some questions. I have one right here in my hand from one of the audiences. Please write down your questions if you have some, and pass them down to some of our staff, and bring it to me. Thank you very much. So how's your trip to Bangkok?
Outstanding.
Is this your first time, sir?
No, my second time. I have been to Thailand in 1990.
Wow.
And I was remarking at the table at how much has changed.
I see.
In roughly 20 years.
Right. Change in other not
for
climate.
the better. not necessarily the climate, but I remember bicycles and tuk-tuks.
Ah, I see.
I haven't seen a tuk-tuk since I've been here.
Really? Ah, so you haven't really arrived.
No, I haven't.
We'll have to show you.
Yeah.
Actually, I used to live in California during the 80s. I grew up in the valley, San Fernando Valley, and lived there for quite a few years. I went to UCLA, enjoyed staying in the United States very much. And I came back here in 91. Gosh, a lot changed since I left in 78. Yeah.
Well, you went through the .com. You managed to miss that. That was probably a good thing.
That's right. Back then there was no internet, nothing,
Yeah.
not even mobile phones. But anyway, we caught up on the Facebook thing.
Yeah.
Yeah. So we're waiting for questions. Everything's crystal clear. All right. Oh, by the way, how's our former Vice President Al Gore? How's he doing now?
Well, he's doing very well. As a matter of fact, without dropping names, I was at a meeting with the vice president about 3 months ago, and we're thinking of a new way to try to communicate climate change science to the public and also to policymakers like many of you out here in the audience, and to do it in a way that we use some of the most modern information technology, using Wiki, if you could imagine, as a mechanism for reviewing and communicating climate change science.
Using Wiki?
Wiki, exactly.
Wiki.
It's
the Wikipedia thing.
Wikipedia, and it would become a dynamic, evolving assessment process that allows, within reason, anyone who wants to contribute to be part of this discussion.
Okay. Very good, very good. Okay. You have any jokes?
Well, I'm a dean, and they say there are three kinds of deans, those who can count and those who can't. You have to think about it.
I am. 3 kinds of dean, those who can count and those who can't.
That's right.
What's the third one?
You can't count?
Got it. Okay. All right. มีคำถามไหมครับ ขอเชิญเลยนะครับ
I know it's tough in a setting like this to come up with questions.
Okay, all right. He must be a doctor. It's like writing prescription. I'll go with the one that I can read. Okay. ลายมือเหมือนหมอตอนเขียนใบสั่งยาเลยนะครับ Okay, according to your lecture this evening, you talked about rice production, cassava productions that were affected by climate change. So I'd like to know, does any impact affect to coastal resources like mangrove, seagrass, sea animal, and other marine animals?
Well, that's a good question, and it is certainly relevant to food production here in Thailand. And you know, some of the more dramatic changes in the global climate system are actually taking place in the oceans. Not only is the sea level rising, but I think many of you probably are aware of the fact that the acidity of the oceans are changing, and they are changing in ways that are becoming toxic for certain types of marine life, particularly at the very bottom of food chains. And the acidity is coming from the additional CO2 in the atmosphere. So as the atmosphere becomes relatively more saturated with CO2, that CO2 begins to sort of, if you will, force itself into the ocean surface layers and begins to mix. And as it mixes, it lowers the pH, or makes more acidic the ocean. It doesn't take much of that to cause the ocean to some extent become toxic to coral, for example. And we're worried that very delicately balanced coastal ecosystems, like the mangroves, are going to be affected very negatively by this acidity. Now, in addition to that, as if it weren't bad enough already, as sea level rises on average, the thing you have to keep in mind is that the storm surges and the kinds of severe weather events that happen at coastal boundaries are non-linearly affected. That's kind of a fancy way of saying a little bit of a change in sea level means you get a large change in the size and the power of storm surges. So there's the potential then for cyclones, hurricanes as they call them where I come from, to be that much more destructive of coastal ecosystems. And these are areas that provide a lot more than just you know, habitat for fish. They also provide a buffer for storm surges, and they, to some extent, protect those coastal areas where, of course, a lot of people live.
Like what happened to Burma a few years back with Nagis storm, could that happen to Thailand as well, since we have similar geographical location?
Yeah, well, it's certainly, not knowing the full, all the characteristics of the Thai coastline, in any of the low-lying areas where, you know, Bangkok would be a good example, where you're only a few feet above sea level.
True.
With a increase in sea level of 1 meter, you could expect perhaps a doubling of the size of the storm surges with any given storm above what they are today. So that would be, to some extent, catastrophic.
Right. Okay. Next question. Oh. Do we have limitations for the question? Two more. Okay. 3 more. Okay. Yes, sir. We have a lot of questions, but we'll let you answer 3 more, and then we'll give you the rest. You can do it at your office, or have your students do it.
I've got a long plane ride back. I'd be happy to use that
Great.
time
Yes, sir.
wisely.
Okay. All right. Oh, this one is regarding genetically improved rice. The person asks, are there any possibilities of genetically improved rice to cope with global warming and extreme climate change?
Well, I did show an example of some work that was done by some Japanese scientists whose target was to try to improve the ability of rice to withstand high temperatures and still be able to produce biomass and eventually more grain yield. I think that kind of work is necessary. I don't by any means advocate for genetically modified crops as the only way to go. I still think that we still have a potential to use conventional breeding techniques to increase productivity. But I have to tell you, quite honestly, we're beginning to run out of potential for major gains through conventional methods. So what does that mean? It means that eventually we're going to have to start to learn at a very fundamental level what the biological markers are, the genetic markers, for increasing the ability of these crops to grow under increasingly stressful environments. If that means genetic modification, then it eventually is what will have to happen. Now, I have to tell you that in spite of all of the hype that one hears about genetically modified organisms, we still have a very long ways to go before we will have made significant inroads into creating new genetically modified strains that retain the characteristics, the traits that we want them to have with the new genetic architecture. Plants have this very aggravating habit of when you change something by inserting a gene in them, of eventually, and getting a desired outcome. Let's say it becomes a relatively more effective user of water. It has a way of compensating and changing other parts of its biology to essentially neutralize that very positive gain in subsequent generations. So we really are facing still an uphill battle, but it's one that we're going to have to fight. And I think that as we get better at it, society will become relatively more confident in what we're accomplishing, and that we are, in fact, creating new crops, new strains, new varieties that give us tremendous advantages over the current.
Thank you, sir. Now, this one I like. You said that when temperature rises, tropical countries like Thailand will have more rainfall. Did you say that?
No.
Oh, you didn't? Okay.
I think it can happen.
Oh, okay.
Yeah.
Okay, this person assumed that you said when temperature rises, tropical countries would most likely to have more rainfall. So why, if there's more rainfall, will there be a reduction in crop yield? That's the question.
Well, it's a good question regardless of what I said, because there are, I can't say for sure whether or not Thailand, for example, will get wetter or get drier. I do know that the precipitation patterns will change in Thailand, but I think it's still quite early to be able to say exactly which direction it's going to go. But having said that, there will be places on Earth where the rainfall will increase, and at the same time, the temperatures will go up. And one would think that that would be a good thing for agriculture. Well, in some areas, it will be for a while. But what will happen is that as the temperature continues to rise, evaporation, this is a very simple physical relationship, evaporation will have to increase. And as that evaporation increases, eventually evapotranspiration, which is a fancy term for saying how plants both transpire, they kind of sweat to stay cool, just like you and I, and regular evaporation around them will overtake that additional rainfall, and you will actually see, for all practical purposes, drying out. And that's why eventually it will become bad for crops.
I see. Crop reduction.
Yes.
As you said. Okay. That makes sense. All right. Next question. How do we cope with changing temperature? Turn on the air condition?
Well, the first thing you do, this is a problem that is going to have to be confronted both in terms of adaptation and also in terms of trying to stabilize the climate. Now, you may recall one of my slides, I showed what the effect would be on Thai agriculture, or yes, it was Thai and Asian agriculture in general, if we were to bring the greenhouse gas concentrations to a steady state at about 20% higher than it is today. That gives us a target to shoot for, because we know we're not going to be able to just decelerate the rate at which greenhouse gases are being emitted down to zero. That isn't practical, nor would we really want that. We would give up way too much economic welfare for that to happen. But we can slow it down, and I think that working to reach some kind of a threshold like the 550 stabilization number that I showed earlier is a good start on that. So that's one. And then from just temperature alone, I mean, that's one where agricultural research is making very large breakthroughs, not only in helping crops continue to thrive in higher temperature environments, but also providing for cooling mechanisms around fields, like improving air circulation and making different kinds of changes to conservation or tillage practices that conserve water and make for a cooler environment.
Okay, the last question. This one is quite complicated and sophisticated. I'll read it very slowly. What research priorities relating to mitigation and adaptation options should Thailand focus on in the context of climate change and variability in order to face the future challenges in energy and environment, for example, the context of food and fuel?
Is one of my students out there asking this question? No, I mean, again, it's a complicated question with a very simple answer. I think that it's time to take climate change seriously, and to begin not to dramatically change, how we plan our research and how we target the kinds of knowledge that we need to have, but to do it in a very reasoned and systematic way, so that we begin to think about climate change as an extension of how we deal with climate and weather risk today. And we know that El Nino and La Nina are major influences on the climate system on shorter time scales. We know that variability in the monsoon, again, is an artifact of an internal functioning of the climate system that is coupled to climate change, but it also, to some extent, is independent of it. Well, it makes sense to develop the kinds of tools necessary to deal with that kind of climate variability risk as a first step toward developing the toolkit one needs to adapt to a much longer and sustained climate change. So that's my advice. You can't have too much knowledge about climate change and its potential consequences. And it has to come from the scientific community in a way in which it is non-threatening, that it is as factual as it can be. And this is very important, that we as scientists have to be very clear about what the uncertainties are. What do we know? What do we know as fact? And what do we know less well, but yet we consider to be valuable scientific knowledge? And what is pure speculation? Because I think the public, and to a lesser extent, the policy community that depends on scientific information about climate change has not been given that level of clarity of what we know and what we don't know.
Professor, thank you so much.
Thank you. It's been a real pleasure.
ครับขอบคุณมากครับ Wow, shook his hand. Excellent.
Thank you.
Group photo ใช่ไหมฮะเอามอบของก่อนนะครับ ในช่วงนี้ครับ there will be a gift, a token of appreciation presentation by His Excellency the Minister of Agriculture and Cooperatives ในช่วงนี้กับผมให้กราบเรียนเชิญพระท่านธีระวงศ์สมุทรได้ขึ้นมามอบของที่ระลึกแด่ Professor Easterling ด้วยครับขอเสียงปรบมือแด่ท่านรัฐมนตรีครับ The Minister of Agriculture and Cooperatives, Mr. Thira Wongsamut, would like to present a token of appreciation for our professor.
Perhaps I could give you.
Thank you, sir.
Thank you.
หลังกรุณา please move towards the center of the stage for spectacular PR photo on tomorrow morning's newspaper.
Thank you so much. Thank you.
Next, I have สำหรับ Professor ป่ะครับครับ one more two gifts ลำดับต่อไปครับกราบเรียนเชิญท่านปลัดกระทรวงเกษตรและสหกรณ์นะครับท่านปลัดเฉลิมพรได้ขึ้นมามอบของที่ระลึกแด่พระท่านรัฐมนตรีว่าการกระทรวงเกษตรและสหกรณ์ครับ Next, the Permanent Secretary of the Ministry of Agriculture and Cooperatives would like to present a gift to His Excellency the Minister of Agriculture and Cooperatives กราบเรียนเชิญท่านปลัดด้านนี้เลยครับขอบคุณครับและขอเรียนเชิญพระท่านรัฐมนตรีและท่านปลัดแล้วก็ Professor Easterling ได้ยืนอยู่บนเวทีก่อนนะครับ May I ask for the three gentlemen to remain on stage for our first group photo กราบเรียนเชิญท่านเอกอัครราชทูตประเทศนิวซีแลนด์ May I invite Excellency the Ambassador from New Zealand the Ambassador of Israel Chargé d'Affaires from the Australian Embassy Mr. Simon. และคณะกรรมการบริหารของสวกทุกท่านเลยครับกราบเรียนเชิญครับในช็อตนี้นะฮะในช็อตนี้เดี๋ยวมีช็อตอีกช็อตหนึ่งต่อนะครับ and all the board members of ARDAสำหรับช็อตต่อไปนะครับ next group photo กราบเรียนเชิญ the rest may please remain on stage ท่านกรรมการสวกต้องอยู่ด้วยนะครับถูกไหมฮะเดี๋ยวอย่าเพิ่งลงนะครับ one more shot sir one more นะฮะเดี๋ยวมีอีกนะครับทุกท่านเหมือนเดิมครับนะฮะกราบเรียนเชิญท่านทิบดีกรมการข้าวนะครับท่านรองเลขาธิการสำนักงานการปฏิรูปที่ดินเพื่อเกษตรกรรมท่านเลขาธิการสำนักงานเศรษฐกิจการเกษตรท่านทิบดีกรมส่งเสริมการเกษตรท่านทิบดีกรมปศุสัตว์ท่านผอ.สำนักงานพัฒนาการวิจัยการเกษตรขึ้นมาแล้วนะฮะท่านปิติพงษ์พึ่งบุญนาทิยาครับท่านประธานกรรมการบริหารสำนักงานพัฒนาเศรษฐกิจจากฐานชีวภาพท่านปลัดกระทรวงวิทยาศาสตร์และเทคโนโลยีนะครับท่านพรชัยรุจิประภาขอเรียนเชิญท่านรองเลขาสำนักงานคณะกรรมการวิจัยแห่งชาติครับคุณกาญจนาปานข่อยงามและท่านนายกสมาคมวิทยาศาสตร์แห่งประเทศไทยแนะพระบรมราชูปถัมภ์นะครับท่านศาสตราจารย์ดร.คุณชายชิสนุสันสวัสดิวัฒน์ครับและท่านทิบดีกรมชลประทานครับงั้นเดี๋ยวต้องขอความกรุณาทางสตาฟของเราจัดนะฮะองค์การถ่ายภาพครั้งนี้สักเล็กน้อยครับกราบเรียนเชิญท่านรัฐมนตรีก้าวมาข้างหน้าหน่อยได้ไหมครับนะฮะคงจะต้องซ้อนไหล่กันสักเล็กน้อยเชิญครับ The Minister step forward along with Professor Easterling นะฮะช็อตนี้จะเป็นช็อตเจ้าภาพร่วมนะครับนะฮะของการจัดงานในครั้งนี้ครับแล้วก็สงสัยคงต้องเรียงตัวเลยครับนะฮะหลังจากช็อตนี้เสร็จนะครับกับผมใครขอเรียนเชิญท่านที่ขึ้นมาถ่ายช็อตแรกนะครับได้กรุณาลงไปพักผ่อนด้านล่างนะครับช็อตนี้เราจะขอเรียนเชิญพระท่านรัฐมนตรี Professor Easterling แล้วก็คณะผู้จัดร่วมนะครับจากทั้ง5องค์กรครับนะฮะครับฉะนั้นช็อตแรกลงไปพักผ่อนด้านล่างนะครับ Thank you very much Excellencies Ambassadors นะฮะเดี๋ยวที่ขึ้นมาชุดหลังนี่ยังอยู่ต่อนะครับนะฮะ one more shot with theช็อต2นะครับก็คือท่านทิบดีกรมการข้าวนะฮะท่านรองเลขาสำนักงานปฏิรูปที่ดินเพื่อเกษตรกรรมท่านเลขาสำนักงานเศรษฐกิจการเกษตรท่านทิบดีกรมส่งเสริมการเกษตรท่านทิบดีกรมปศุสัตว์นะครับท่านผอ. ดร.นภาวันอยู่แล้วนะครับท่านปิติพงศ์ท่านพรชัยนะครับและท่านรองเลขาธิการสำนักงานคณะกรรมการวิจัยแห่งชาตินะครับท่านนายกสมาคมวิทยาศาสตร์แห่งประเทศไทยและท่านทิบดีกรมชลประทานครับช็อตนี้เป็นเรียกได้ว่าเป็นเจ้าภาพร่วมนะครับของการจัดงานในวันนี้เอาละครับขอเสียงปรบมือดังๆให้กับทุกท่านบนเวทีอีกครั้งหนึ่งครับขอบพระคุณมากครับอิจฉาท่านผอ.นภาวันนะครับครับส่วนวันนี้นะครับในนามของคณะกรรมการผู้จัดงานนะครับกับผมต้องกราบขอแสดงความขอบคุณนะครับกับทุกท่านเป็นอย่างสูงที่ได้กรุณามาร่วมงานในวันนี้นะครับ On behalf of the organizing committee, thank you very much for your attendance. We hope we can look forward to seeing you all again very, very soon in our next event. Thank you very much and have a safe trip back home. Good night. ขอบคุณมากครับ สวัสดีครับ